Water. Clear, pure, abundant. It's one of our most precious natural resources and vital to all forms of life. An ample supply of clean, fresh water, billions of gallons a day, is needed by cities and towns throughout our region for household, business, and industrial use. The average home consumes hundreds of gallons of water every day for drinking, cooking, laundry, bathing, and flushing toilets, to tend the garden and fill the swimming pool. Water is also used by stores and restaurants, schools and hospitals, factories, and fire departments. An adequate and reliable water supply is crucial to our quality of life and our region's economy. Nearly half of Massachusetts, including most of Greater Boston, receives water from the Quabbin and Wachusett reservoirs. Located 65 miles west of Boston, the Quabbin is the largest reservoir in the United States built to provide a public water supply. Covering more than 39 square miles, it holds 412 billion gallons when full. Water from this vast supply is delivered to community service pipes in the Boston area by the Massachusetts Water Resources Authority, known as the MWRA. Created by the state legislature in 1985, this agency provides the region's water and sewer services. Over 2 million people and 5,500 industries in 46 cities and towns depend on MWRA for their water. Quabbin water travels to consumers through a delivery system of aqueducts, tunnels, and pipes. The journey begins at the Quabbin Aqueduct intake station. Water released to the system flows 25 miles through the Quabbin Aqueduct to the Wachusett Reservoir, then 8 miles along the Cosgrove Aqueduct to the Hultman Surface Aqueduct for the 18-mile run to the City Tunnel in Weston. The Hultman Aqueduct feeds the City Tunnel, the Weston Terminal Chamber, and other connections that supply Boston suburbs. 85% of the water used by 41 communities is delivered through the Hultman. The other 15% is carried through the Weston Aqueduct, a brick-lined, unpressured channel built in 1903. This water transmission system has served the region well, but increasing dependence on a deteriorating critical delivery link threatens the entire waterworks network. The Hultman Aqueduct has been operating for more than half a century without a backup or the ability to be shut down for inspection or maintenance. It was built in 1940 as the first part of a dual pipeline system. As designed, either one of the pipelines could be shut down at any time to support the maintenance and repair of the other line. But the onset of World War II and decades of underfunding prevented the second line from ever being built. Today, without a reliable backup system, the Hultman Aqueduct could not be out of service for more than a few hours without major consequences. Greater Boston is the only metropolitan area in the United States that depends on a single major pipeline for its water supply. Unlike the Quabbin and Cosgrove aqueducts, which are tunnels far below ground built through solid rock, the Hultman is a pipeline. Over 5,000 pipe segments, 12 feet in diameter and from 12 to 16 feet long, form the 18-mile length of the aqueduct. Currently, the Hultman leaks in over 35 locations. Soil erosion around a leaking pipe joint could cause a joint failure, requiring an emergency shutdown of the water supply system. A major break in the pipeline would propel eastern Massachusetts into a water crisis with devastating consequences. Public health and fire protection would be seriously jeopardized. Business and school closings, industry shutdowns, and hospital evacuations would impact the lives of millions of people who live and work in the area. And the economic impact of a Hultman failure, from $50 to $100 million a day, would threaten our financial security. The MWRA is responding to the critical needs of our water system with an integrated waterworks improvement program. Planning and construction of key facilities are underway to provide reliable and safe water delivery for the 21st century. The program includes 4 major components. An aggressive watershed protection program protects water quality at the source. A new water transmission tunnel, the Metro West Water Supply Tunnel, is under construction to provide a backup for the Hultman Aqueduct. Covered water storage will replace existing open reservoirs in Stoneham, Weston, and at Nash Hill in Ludlow. And MWRA is preparing to construct new treatment facilities to be located in Marlborough, that will assure the highest level of water quality. The Metro West Tunnel is the backbone of the new system. 14 feet in diameter and 17.6 miles long, the tunnel will be mined through bedrock from 200 to 500 feet below ground under 5 Metro West communities: Marlborough, Southborough, Framingham, Wayland, and Weston. When completed in 2003, it will connect the existing tunnel to the new treatment facilities in Marlborough and to the new covered storage tanks in Weston, and then to the tunnel and water mains that serve the communities. An option to rebuild the turn-of-the-century Sudbury Aqueduct was reviewed and rejected in favor of constructing the deep rock tunnel. Underground construction will disrupt communities far less than a 17.5-mile above-ground job site, and the new project will provide better service and allow obsolete aqueducts to be retired. Construction of the Metro West Tunnel reflects the MWRA's commitment to the people we serve.
Throughout the planning and design, we have recognized the effects that a major construction project such as Metro West can have on residential neighborhoods. We've strived to develop construction plans and procedures to limit and reduce those impacts.
MWRA is taking many steps to shield the neighborhoods near work areas from the worst impacts of construction. On-site batch plants in Framingham and Southborough will minimize trucking for concrete delivery. An agreement providing for the on-site storage and use of rock excavated from Shaft L in Framingham eliminates the need for trucking most of the 855,000 cubic yards of rock off-site for disposal. Paved access roads, prescribed truck routes, and limited trucking hours all minimize construction traffic impacts on local roads and neighborhoods. Restricted work hours, noise level limits on blasting, and equipment and noise barriers all help control construction noise. Vehicle wheel washes and street sweeping limit the tracking of mud onto the roads and control dust. A water contingency plan protects residents from any tunnel construction-related service interruptions. Emergency water lines have already been installed in areas where tunnel construction may impact residential wells to respond immediately if there are any water delivery problems. To protect the environment, all tunnel water inflows are passed through a treatment plant and discharged in compliance with a state-issued permit. Throughout the project, MWRA will work closely with local officials and residents of communities affected by the construction. Together, we will continue to resolve project concerns with creative and practical solutions that work.
All of our efforts support the major goal of the project to safely build a water delivery system while minimizing disruption.
The scope of work for all major components of the Metro West Tunnel project is divided into a series of contract packages, 3 for the tunnel and several for surface facilities. Construction work for all contracts is integrated, sequenced, and scheduled so that all parts of the system come together as smoothly and efficiently as possible. Safety concerns about the hazards of descending to and working in a confined underground enclosure make it necessary to limit access to the job site during construction. So this part of the program is designed to provide a safe tour of a hard rock tunnel construction site. Beginning at the staging area for Contract 2 in Framingham, Shaft L has been excavated 410 feet down through soil and rock to tunnel level. At the base of the shaft in what is called the bottom station, 2 tunnel boring machines have been assembled. Mining east and west concurrently, these machines cut 16-foot bores along the 11.8 miles of the center span of the tunnel alignment. At the same time, work sites have been set up at shafts E and 5A. A third tunnel boring machine, launched from shaft E in Southborough to mine the 4.9-mile western end of the tunnel, will finish at shaft D in Marlborough, where the water treatment facilities will be built. Finally, the 4,400-foot section of tunnel on the eastern end from shaft 5A to shaft W will be mined concurrently. The covered storage facilities will then be tied in at shaft W and at intermediate shaft N in Weston. Now we'll take a closer look at each step of the construction process. Back at the